Let us solve the linear differential equation, a Libnitz equation. Libnitz equation dy by dx plus py equal to q. This is the Libnitz equation where p and q are functions of x. So its solution is y into integrating factor equals to integration of q into integrating factor plus c. Let us look the example. Dy by dx equals to minus x plus y cos x divided by 1 plus sin x. So this equation becomes dy by dx plus x plus y cos x divided by 1 plus sin x equal to 0. So the equation P is equal to cos x upon 1 plus sin x and Q is equal to minus x upon 1 plus sin x. Integrating factor is equal to e raised to cos x divided by 1 plus sin x into dx, which is equal to e raised to log 1 plus sin x. So e and log x cancels, integrating factor becomes 1 plus sin x. So y into 1 plus sin x is equal to integration q minus x 1 plus sin x into 1 plus sin x dx plus c. So y into 1 plus sin x equals to x square by 2 plus c. Hence the equation becomes y bracket 1 plus sin x plus x square by 2 is equal to c. This is x square by 2. Let us look the another example. Y e raised to y dx equals to y cube 2x e raised to y dy. So dx by dy equal to y cube 1 plus 2x e raised to y upon y into e raised to y. So this implies dx by dy equals to y cube 1 plus 2x into e raised to y divided by y into e raised to y. So dx by dy is equal to y square upon e raised to y plus 2x upon y. Hence dy by dx minus 2x upon y equal to minus y square upon e raised to y. So integrating factor in this equation is e raised to minus 2 by y dy. So it is equal to e raised to minus 2 log y, which is equal to 1 by y square. So its solution is x into integrating factor 1 by y square equals to integration y square upon e raised to y into 1 upon y square dy plus c. So x upon y square plus 1 by e raised to x is equal to c. Is the solution of the Libnitz differential equation. Look this. Now let us look the another differential equation. Let us know the Bernoulli's equation dy by dx plus py equal to q into y raised to n. So multiply y to the power minus n on both the side of this equation, we get dy by dx into y to the power minus n plus p y to the power 1 minus n is equal to q. So put y to the power 1 minus n as its head and differentiate with respect to x equal to 1 minus n y to the power minus n dy by dx. Differentiated x to the both side. So dz by dx plus 1 minus n dz by dx the 1 minus n y to the power minus n dy by dx equal to dz by dx. Hence y to the power minus n dy by dx equal to 1 upon 1 minus n dz by dx. So equation becomes dz by dx plus 1 minus n pz is equal to 1 minus nq. So let us know the problem. Simple problem. Dy by dx plus minus 1 by x y is equal to x y to the power square. So dividing y square y power minus 2 to both sides, minus 1 minus x y to the power minus 1 equal to x. Put v is equal to 1 by y, that is y inverse. So dv by dz equal to minus 1y to the power minus 2 dy by dx. So minus dv by dx minus dv by dx equal minus 1 by x into 1 upon y square is equal to x. So integrating factor is e raised to minus 1 by x dx. It is e raised to log x, which is equal to x. So z into integrating factor minus x into x dx plus c. So x by y plus x cubed by 3 equal to c. This is the required differential equation. Let us look the another linear differential equation of second and higher order with constant coefficient. Linear differential equation of second and higher order with constants coefficient d2y by dx square plus dy by dx is equal to minus 2y equal to 0. So in such a differential equation, put d by dx is equal to d and d2y by dx square equal to d square. So auxiliary equation is d square plus d minus 2 into y equal to 0. So auxiliary equation is a d square plus d minus 2 equal to 0, which is a quadratic equation, and its roots are d plus 2, d minus 1 equal to 0, d equal to minus 2, d equal to 1. So complete solution is y is equal to e raised to e to the power minus 2x plus c2 e to the power x. Here the roots are in the form y is equal to c1 e raised to m1x plus c2 e raised to m2x plus c3 e raised to m3x and so on. So using this equation we get a complete solution of the differential equation y is equal to c1 e to the power minus 2x. Here minus 2x is a m1, which is the root of quadratic equation, and e to the power x is equal to this x is equal to root 1. So let us look the another equation. d2x divided by dt square plus 3a dx by dt minus 4a square x equal to 0. So in that case, find auxiliary equation d square plus 3ad minus 4a square into x equal to 0. So quadratic equation is root as d plus 4a and d minus a equal to 0. So d is equal to a and d is equal to minus 4a. Hence complete solution is x is equal to c1 e to the power 80 plus c2 e to the power minus 480. Now let us look the another example. d2y by dx square plus dy by dx equal to 0. D square plus d into y equal to 0, and we get d is equal to 0 and d is equal to minus 1, root of this equation. So solution is y is equal to c1 e to the power 0 x plus c2 e to the power minus x, which is equal to c1 plus c2 e to the power minus x. Let us look the another equation. d2y by dx square minus 4 dy by dx plus y equal to 0. Here roots are d square minus 4d plus 1 into y equal to 0. So d square minus 4d plus 4 is equal to minus 1 plus 4. The 4 is added to the both side. So we get d minus 2 whole bracket square equal to 3. Hence roots are d is equal to plus minus root 3 plus 2. Its complete solution is y is equal to c1 e to the power root 3 plus 2 x plus c2 e to the power minus root 3 plus 2 x. Now let us move the another differential equation. d2y d2x d2x by dt to the power 4 d to the d4 to the power x dt4 plus 4x is equal to 0. So its auxiliary equation is d to the power 4 plus 4. So its quadratic equation becomes d to the power 4 plus 4d square plus 4 minus 4d square is equal to 0. So we get root d equal to minus 2 plus minus 4 minus 4 divided by 2 and 2 plus minus under root minus 4 by 2. So d equal to minus 1 plus minus I and 1 plus minus I. These are the two roots. So x is equal to e to the power minus t c1 cos t plus c2 sin t plus e raised to t c3 cos t plus c4 sin t. So this is the required expression of this equation. If note, if roots are same, if the roots are same, that is d equal to 1 comma 1 comma 1, so it's a complete solution. Y is equal to c1 x to the power 2 c2x plus c3 into e to the power x if the roots are same.